In our sky is this one star, either ball or bug squeeze, a red monster star. Assuming you put it where the Sun is, it would reach out to the circle of Jupiter. It's colossal and truly unsteady, going to detonate. Prepare for an enormous fiasco of never-before-seen scale. Betelgeuse, the red monster star on the edge of our system, is sending terrifying signs through space. Cosmologists have found something profoundly disturbing about this tremendous article in space, utilizing the James Webb Space Telescope. Notable researcher Brian Cox has given an intense admonition. The inquiry that continues to come up is, are we going to see a cosmic explosion blast that will be so gigantic it will change the night sky forever? We should bounce right into the infinity of the universe. Stars are conceived, live, and die in astounding ways. As of late, one star has grabbed the attention and stress of both cosmologists and ordinary people. This is Betelgeuse, a red, very giant star that hangs out in the constellation Orion. It is extremely large and very old. Its extraordinary rosy variety and changing brilliance have for quite some time been intriguing. Yet, late events have made people considerably more interested in this celestial monster. As we more deeply study Betelgeuse, we are nearing a potentially critical event in its history. But what could these changes in Betelgeuse mean? Are we seeing the beginning of a vast show on an unfathomably immense scale? Betelgeuse is a heavenly giant. It is multiple times greater than our Sun. It is so gigantic that it's difficult for people to comprehend. Imagine a star that is so large that if it somehow happened to replace our Sun, its surface would reach past Mars' circle and fold over Mercury, Venus, Earth, and Mars. Not only does this enormous size show how astonishing Betelgeuse is, but it also shows what phase of its life cycle it is in. As a red supergiant, Betelgeuse is approaching the end of its life. It is growing and cooling during this stage, which comes after transforming hydrogen into helium in its center. What about Betelgeuse's age? This star is believed to be somewhere in the range of 8 and 8.5 million years old, which is young in human years but extremely old in terms of celestial lives. It has been changing dramatically over millions of years, going from a blistering blue star to the red giant we see today. It is now in its last stage as a red supergiant. Stars like Betelgeuse change over the course of their lives due to the constant pressures of atomic fusion and gravity. Something else that makes this phase of Betelgeuse stand out is its remarkable ruddy color. Its red color comes from the fact that its surface is cooler than the surfaces of other stars like our Sun. The outer layer of the Sun is around 5,500 Kelvin, while the outer layer of Betelgeuse is around 3,500 Kelvin. Since it is cooler, Betelgeuse can radiate light at frequencies that make it look red. But this color isn't just for show. It tells us something about the star's actual state and the processes happening inside its enormous, gaseous volume. The fact that Betelgeuse's color has changed over time adds to its mystery. Ancient writings from the Roman and Chinese periods say that Betelgeuse was yellow around 2,000 years ago. In the 9th century, Arabic scientists were the first to say it was red. This shift in color over the course of humanity's history isn't a trivial detail in the field of science. It also shows how the star has developed. Another interesting thing about Betelgeuse is that its brightness changes over time. It's a semi-regular variable star, meaning its brightness goes up and down regularly. This dance of brightness has captivated scientists and skywatchers for many years. Typically, Betelgeuse goes through a 200-day cycle and a longer cycle that lasts for several years. As early as 1836, Sir John Herschel wrote about these cycles, and Native Society chronicles might go back even further. But what really makes Betelgeuse puzzling isn't just that its brightness changes, but how irregular it is. Unlike many stars that dim and brighten in a predictable manner, Betelgeuse sometimes deviates from this pattern. This suggests that complicated and less understood processes are occurring inside its colossal structure. Recently, astronomers and stargazers around the world were stunned to see Betelgeuse's appearance change drastically and suddenly. This is now known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, which is one of the brightest stars in the night sky and a prominent feature of the constellation Orion, began to dim in a strange way. The star was getting so faint that it started losing its light at a rate of 0.01 magnitudes per day. By February 2020, it was at its dimmest. Betelgeuse, which can usually be seen with the unaided eye, even in places with a lot of light pollution, got much fainter, and even casual observers could see the difference. The time delay, on the other hand, makes it hard to keep track of what Betelgeuse is doing because light takes so long to reach us. When we look at a star like Betelgeuse, we don't see it as it is now but as it was in the past. For Betelgeuse, the light we see today left the star nearly 725 years ago. Since it is about 725 light-years away, we are looking into the past of the star. This delay makes it difficult to predict and monitor rapid changes in its behavior. The Betelgeuse dimming event was a reminder of how challenging it is to observe the sky in real time and how little we know about the vast, strange worlds that exist out there. Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely monitored the events of Betelgeuse's celestial display as part of a 3-year study to track changes in BJ's outer environment. They used the Hubble Space Telescope to observe the massive star. These observations provided a new insight into how a variable star like Betelgeuse functions. Variable stars regularly grow larger and smaller, which causes changes in how bright they are. Scientists were able to investigate the layers above the star's surface, which were heated in part by the star's swirling convection cells. Thanks to Hubble's ability to detect ultraviolet light, more investigation of the Hubble spectra, taken at different times in 2019 and 2020, helped sort out how fast things were moving in Betelgeuse's upper atmosphere. The spectra were mostly composed of magnesium-2 lines, which show what the star's environment is like. The studies revealed that things were moving from the star's surface into its atmosphere at around 200,000 miles per hour. This hot, dense material finally reached millions of miles from Betelgeuse. It was the beginning of the dust cloud that made the star less bright during the 3 months of the dimming. Dupree and her team felt that about twice as much material as expected from Betelgeuse's southern hemisphere was lost. While all stars lose mass over time, Betelgeuse's loss was especially noticeable because it occurred at a much faster rate than the Sun's. Astronomers discussed whether this event could be a sign of a supernova blast, given how massive this mass loss was and how faint the star became afterward. Being about 725 light-years from Earth, Betelgeuse adds to the mystery because any explosion like this would be visible from Earth and give people a rare chance to witness a supernova up close. But the question still stands: how might this dimming affect Betelgeuse's future? Is it a sign that a supernova explosion is going to occur, or is it a one-time event in the star's long and complicated life? Several ideas were proposed to explain this rapid change. One popular hypothesis suggested that there was a phase in the process of a supernova explosion. This theory gained traction because most people believe that Betelgeuse is nearly finished with its life. Another common idea is that dust, perhaps from the star itself, is blocking our view. It is known that Betelgeuse and other red supergiants lose matter. It was thought that this matter could form a dust cloud thick enough to block our view of the star's light. A third idea involved how changes in the star's photosphere, the visible layer on the surface, could significantly affect how bright it appears. This mystery was solved by using many observational techniques and in-depth analysis. Spectroscopic examinations showed that Betelgeuse's effective temperature decreased. This suggests that the star might be dimming due to a large dark spot on its surface. The fact that Betelgeuse's temperature decreased by at least 170 Kelvin around the time of the dimming supported this idea. This showed that there were significant changes on the star's surface. The fate of Betelgeuse has become one of the most fascinating topics in modern astronomy, and many astronomers are eagerly awaiting more data to refine their understanding. The star's eccentric behavior continues to ignite conversations about the nature of celestial death and supernovae. Some astronomers believe that Betelgeuse may be on the verge of a dramatic change that could offer a brief glimpse into the final stages of a massive star's life, a supernova explosion. When it happens, it could briefly eclipse an entire galaxy, making it visible even in daylight. Witnessing such an event in real time would be both thrilling and humbling, offering an incomparable display like no other. The impending blast of Betelgeuse, if it happens soon, could offer valuable insights into the mechanisms behind supernovae. Scientists are increasingly turning to complex simulations and models to predict when and how the star's death will unfold. They are also looking at past supernova events to better understand how stars like Betelgeuse behave in their final moments. While there is still much uncertainty, researchers are hopeful that Betelgeuse will reveal key details that will help them answer fundamental questions about stellar evolution, including why some stars explode as supernovae while others collapse into black holes. This ongoing research into Betelgeuse's behavior has already provided valuable data. and scientists are hopeful that it will shed light on some of the most fundamental aspects of stellar life cycles. The mass loss observed in Betelgeuse, which is occurring at an accelerated rate compared to other stars, offers a unique opportunity to study the processes that lead up to a supernova explosion. It's also giving astronomers a deeper understanding of how stars like Betelgeuse lose mass in the final stages of their lives. In addition to the scientific implications of Betelgeuse's behavior, the star also serves as a reminder of the incredible complexity and dynamism of the universe. The fact that such a distant star can have such a significant impact on our understanding of astrophysics speaks to the interconnectedness of all celestial bodies and how they can inform one another across vast distances. As scientists continue to monitor Betelgeuse and refine their models, we may soon be able to predict with greater accuracy the exact moment when this massive star will reach the end of its life and explode in a spectacular supernova. For now, though, the mystery surrounding Betelgeuse remains a source of fascination and speculation. Whether or not it's on the brink of a supernova explosion, one thing is certain: Betelgeuse will continue to be a key focus in the study of stellar evolution and the immense processes that shape the universe. The next few years of observation will likely bring more breakthroughs in our understanding of this fascinating star, and perhaps provide more clues about the ultimate fate of massive stars. The possibility of witnessing a supernova up close, as it happens, is a once-in-a-lifetime opportunity for astronomers and skywatchers alike. The outcome of Betelgeuse's future may hold the key to unlocking even greater mysteries about the universe, and could provide us with answers that help explain the death throes of stars and the formation of new celestial bodies. Whatever happens next, Betelgeuse will remain a prominent subject of study, offering scientists a rare chance to observe the end of a massive star's life in real time. Whether it explodes in a brilliant supernova or goes through a different kind of transformation, it's clear that Betelgeuse's story is far from over, and it will continue to fascinate and intrigue those who study the stars for many years to come.